All right, proof of an inverse. Hopefully we have memorized that an inverse means that we're going to switch all the x and y values. So whatever the x value is of the function, its inverse function will have those things transposed. That is to say that the y values will be in the x position and the x values will be in the y position. However, it's not good enough to just be able to say, for example, in this case, let's see how that would work. You can say that f of 1 equals 5 times 1 plus 1/3 equals 5 1/3. So we have the point 1, 5 1/3. If that's true, if this is the inverse, then it would be true that 1/5 times 5, what is this, 15, 16 thirds minus 1/15 would have to equal 1. And if we look here, we get 16 over 15 minus 1 over 15 is equal to 15/15, which is equal to 1. Right? That's proof that we switch the x and y values. But that's not counted, by convention, it's not counted as proof. The proof of an inverse function has to be done this way. So when your teacher or your professor asks you for proof, doing what I just did is not good proof. But what is good proof is to use a composite function and say the inverse of f of x is equal to x. So we're going to actually build that. So we're going to start off by saying the inverse of f of that thing that we're going to use is equal to 1/5 times x minus 1/15. And then what we're going to do is we're going to take our f of x function, and our f of x function is up here, is this one, and we're going to plug that in here and say 5x plus 1/3. Right? Excuse me. And then we're going to show this as our proof to our professor. And we're going to multiply this through, and it gives us 1/5 times 5x is x. 1/5 times 1/15 is 1/15. We already had this negative 1/15 right here. And when we do this bit of arithmetic, we get x plus 1/15 minus 1/15 is in fact x. Check mark. That's the proof. So remember, the other way to do it, and I won't push you through it, is to do it the other way around and say that f of the inverse of f of x would also be equal to x. So those are the two ways you can prove it. This is a pretty basic solution. So hopefully this was helpful. If you haven't already subscribed, please do, and your comments are always welcome. Thanks.